Okay, so for the warm-up yesterday, you guys revisited how to take a square root and basically simplify it. You're going to need that information to do this for today. Now, this is going to be seen in Algebra 2 a lot, so it's important that you get these notes down. So rationalizing the denominator, all that means is that you're get rid of the square root that's in the denominator. You can never have the square root in the bottom of a fraction. And when we refer to radicand, a radicand is everything under the square root, okay? So for the first thing, to make it simplified, so no radicand can have perfect square factors. So like if you had the square root of 8, you can't have that because it's not simplified, because 4 times 2 is 8 and 4 is a perfect square. Obviously 1 will be in all of them. And you can't have fractions in your radicand, so no radicand can have fractions. And you can't have any square roots in the denominator of a fraction. And that's why we have to do what's called rationalize it. So no radicand can have perfect square root factors such as 8 because that breaks down into 4 times 2. You can't have a radicand like something like that. You can't have that. And then you can't have something like this. You can't have a square root in the bottom. So all of those we have to clean up. So if you want to rationalize a denominator, so just to kind of refresh your memory, if I had the square root of 5 and I multiplied it by the square root of 5, that would just give me 5, right? Because the square root of 5 times itself, it undoes it. It's like saying the square root of 5 squared, and squaring and square root, they wipe each other out. So in order to rationalize the denominator, what you're going to have to do is multiply top and bottom of the fraction by the square root in the bottom. Okay, the reason we multiply top and bottom is you want to keep the expression the same. So if you only multiply the bottom, you're changing it somehow. So if I multiply something by, as an example, if I multiply something by the square root of 5 over the square root of 5, that's the same as multiplying by 1. So I am changing what it looks like, but it still has the same value. Okay? So for number 1, we want to break this down into the square root of 1 over the square root of 26, because you can't have a fraction underneath. The square root of 1 is just 1, and the square root of 26. The square root of 26 cannot be broken down. So in order to rationalize it, you take what's in the bottom and you multiply both top and bottom by that square root. You then multiply across. 1 times root 26 is root 26. Root 26 times root 26 is just 26. And that would be your final answer. If you put this in your calculator and this in your calculator, it's the same exact value, but this is not considered simplified because you cannot have a square root in the bottom. So if you look at this, square root of 5 over square root of 3, I have square root of 3 in the bottom. So I'm going to multiply the top by square root of 3 and the bottom by square root of 3. Root 5 times root 3 is root 15. Root 3 times root 3 is just 3. And you're finished. Okay. Same thing here. You can break this down into square root of 35 over the square root of 6. Square root of 6 is in the bottom, so we're going to multiply top and bottom by the square root of 6. 35 times 6 is 210 over just 6. 210 does not break down. It does not have any perfect squares. You always need to check at the end, like root 26, root 15. root 210. That can't, you want to make sure that they cannot be broken down any further. Okay, so for this one, you want to break it down into the square root of 8 over the square root of 11. You want to get that root 11 out. So you want to multiply top and bottom by root 11. So you get the square root of 88 over 11. So now 88 can be broken down. Sorry. Anyway, you can break this down into 4 times 22 over 11. You take the square root of 4, which comes out as 2 root 22 over 11. And you're finished because 2 over 11 can't be simplified. Remember, you can't divide these because the square root of 22 is not 22. It's a number way less than that, 4 point something. Okay, there's a couple more on the back to practice. So for the first one, you have the square root of 24. There's different ways you can do this. You can break it down if you want first to make it easier, because you have the square root of 32 over the square root of 24. So if you multiply top and bottom by root 24, that's going to be a huge number. So you may want to break this down. So this is 16 and 2, right? And then this is 4 and 6. So the 16 and 2, the top would become 4 square root 2. And then the bottom would become 2 square root 6. So now all we have to do is just multiply just by that root 6. So on the top you get 4 times 1 is 4. Root 2 times root 6 is root 12. 2 times 1 is just 2. Root 6 times root 6 is 6. So now we have 4 root 12 over 12. Now if you thought we were finished, we're not. Because 12 can break down into 4 times 3. So that 2 comes out. There's already a 4 there. So you multiply the 2 times 4 is 8 root 3 over 12. We're almost done. Treat this as like 8 over 12x. So this right here can be simplified. They're both divisible by 4. So you get 2 root 3 over 3. Ugh. Okay. Fun times. All right. So for the next one, I mean, you can do this a couple different ways. If you think about it, if you had 2 over 7 plus 12 over 7, remember you would keep the base and add, right? So you can do that here. You can keep the base and add those. But now you have to multiply by root 7 and root 7. So you get 14 root 7 over 7. And just like we simplified this, you can simplify that. Okay, so you have like denominators, so you just add the numerator. For number 7, this square root of 18 breaks down. So this would be 3 over, this is 9 times 2, so it would be 3 root 2 plus root 2 over 1. So I wasn't going to do this problem, but I will. So to get rid of this root 2, you want to multiply top and bottom by root 2. So root 2 times 3 is 3 root 2. 3 times 1 is 3. Root 2 times root 2 is 2, so it's 6 plus root 2. 3 over 6 is 1/2, so root 2 over 2 plus root 2. So this is like a 1 root 2, right? So 1/2 root 2 plus 1 root 2 is 1.5 root 2, or 3 over 2 root 2. I really don't think we need to get into like this so much as, you know, just knowing how to do these types and then the front. Okay, so that's all you have to do is take those notes today. I'll have an assignment for these tomorrow. And then the bottom is a whole nother thing that we will pick up on in 2 days. So keep your notes with you so you can finish those.